Hi. Sorry, one sec. Hi, everybody. Welcome to Rod's Office Hours, where we give practical insights from the oil and gas industry. Uh, Tonight's topic is well completions. Um, and as always, please feel free to ask questions in the chat uh, as we go along, and we'll pick those up in the webinar as we go. Um, and we're going to talk about well completions tonight. This was a question that came in from a YouTube viewer. So just going to focus on that for this evening's talk. When we talk about well completions, what is it? Why is it important? Well, the biggest thing when we talk about well completions, we're going from drilling to completing or finishing a well. And it's in the well construction phase, but it is connecting the reservoir to our production facility through the well. And so it's referred to as completing a well. So there's lots of different aspects to completions. It's can be seen as a sort of an in-between step between drilling and production, but choices and things that we do in this phase can have a big impact on the life and the productivity of a well. So, and lots of super interesting technology that's used in this phase. So, but before we get into it, just a little bit about myself. My name is Rod Gibbons. I'm a petroleum engineer and entrepreneur. Been in the oil industry for over 30 years now. And together with my wife, Willow, we work to make doing business in the oil industry better. And a shout out to her for her recent award from SPE. So congratulations to that. So I've had the privilege of working in multiple areas in the world and in multiple roles. And I hope to share some insights with you as that you might not find elsewhere. And if you're in the webinar and then this live, this video will be posted on YouTube. And if you're watching this on YouTube, Wednesday evenings is a webinar. This is a live webinar, and you can sign up for it by scanning this QR code. We'll bring you to the sign up link for the webinar. So just give you a second to scan it. And our YouTube channel is YouTube/Valleycatcher. Okay, so now we'll get back to completions. So we've seen this diagram a couple of times. This is a well life cycle. And so there's many phases to the life cycle of a well. And we have the phases of design, and construction phase, well construction phase, and then operational phase, intervention phase. We spent a bit of time talking about this lately, and then the abandonment phase. This is what we had to manage the well through its entire life cycle. The well construction phase is made up of drilling, which is basically putting a hole in the ground, and completions, which is then making it fit for purpose, fit for use. And this life cycle and these steps that we take, it applies to offshore and onshore operations. So whether you're drilling on land or whether you're drilling in the sea, then this life cycle is the same. And so we'll use the term well construction as including drilling and completions. And so I just want to go through just to go back a little bit on drilling. And so here we have, this is looking underneath a water well rig, and this is a tricone bit. And you see we started in the ground, we're pumping some, this is most likely just straight water here, and we're going to make a hole That's the drilling part. So just have a little look at that, because that sets up everything for completions. So let's just go to the next slide. Okay, so here's an example, offshore example. This is a drill ship, and we put a conductor into the mud line, and again, so we're just going back to the drilling phases here. So we're going to drill a well through the different strata, different layers in geology. So to do that, we start with a bit of a conductor, then we put our blowout preventer, BOP, on, and then in this case, a riser back to the drill ship. On land, the BOP would be on the land rig, and then that allows us to get started to drill the well. And there's a lot of focus on this stage. We've done a lot of design work here, because all these geologic layers, that's pretty big unknown. So that's one of the reasons why we try and minimize risk there as much as possible. So this is an image of, say, the deep subsurface. And so a lot of times in drawings, you'll see that the wellbore, so a wellbore diagram, which is how we represent a wellbore, will be straight up and down on the page. Most wells, almost all wells were drilled like that initially. But now with technology, so this is a mud motor and a drill bit at the bottom of the string. And now we can drill deviated wells or horizontal wells. And so this video just shows how, by sending a signal to the mud motor, it starts to slide, pads push out and push that bit off to the side, so that then you can drill highly deviated or horizontal wells. We still, a lot of times, we'll still draw them as straight up and down, but again, and how we're able to bend that pipe. This train video shows the same sort of thing. The wheels on the train actually don't bend. It's actually just slight changes in deviation, which allow you to have curved tracks. The tracks are still straight; they're just bent ever so slightly, and that's what happens in a horizontal well. Once the hole is drilled, and they're going to show this. So this is cement. So we put pipe in the ground, and then we circulate cement around. And I'll just pause it right there for a sec. We drill a hole through the earth, and then we run steel pipe to give the well stability, so that the rock that's there doesn't collapse in, or that pressures don't communicate from one porous formation to another. So we run that steel pipe, and then we pump cement around and cement that pipe in place. That pipe, so then we refer to it as casing. So when it's cemented in place and you can't pull it out, that's casing, and it goes all the way back to surface. You may also hear the term liner, and that is pipe. This is the exact same, but we run it in, we cement it in place, but we don't run it all the way back up to surface. It's just hung off at the bottom. It's a liner, but it's still just steel pipe cemented in place, and that is well construction. That is building our well and securing it so that the pressure inside the well doesn't interfere or connect with the pressure in the porous formations outside the well in the rest of the subsurface. So we just had an offshore example. This is back on land. So this is a drilling rig on land. And so you can see here, there's a horizontal well been drilled. You can also do what's called multilaterals, where I think it rotates around here. So you have more than one branch of the well bore. So you can have like 2 branches or 3 branches from one well, and then you can come out and have different laterals. So that's drilling the well. So up to this point, we're still in drilling mode. Now, if we just go to, once the well has been drilled, so we need a way to describe what we've done. So we do a wellbore diagram. I'll start with this one. This was a simple one, or simpler. So this is a well completion diagram. It's a single zone cased hole, so it's one productive interval. But you can see how we draw it. And this is so you can see here. Here's a drawing of a horizontal well. Here's a drawing of a vertical well. Because the wells are so deep in the ground, we don't draw them to scale. We make it this shorter, and the side view is much wider. But that just allows us to visualize something that's potentially kilometers or miles deep in the ground and only 7 inches, 200 millimeters around. So the scale is not right, but that's okay. We want to show the information. And so what you'll see is, you can see here, we start with a big hole and then we drill down. This is surface casing. And again, this is a cross section of the well. So we have this and this. You have to visualize it as a big piece of pipe cut in half, and we're just looking at the edges of the pipe. When there's a little triangle on the bottom, that signifies that it's been cemented in place. That's the casing shoe. And so what we're doing is we're putting that steel pipe in the ground, and we're gonna pump cement down around, and we're gonna cement it in place so that it is bonded to the rock, so that there's a complete seal outside of this pipe. Then we'll pick up a little bit smaller drill bit when it fits inside this first pipe, and we'll drill a deeper hole down to here, and then we'll run a slightly smaller pipe and then cement it in place. And we do that because, and then we do the same thing down again. We'll drill a smaller hole and then with a smaller pipe. And we do that because as we get deeper in the earth, the pressures can change. And so this could be higher pressure here than it is up here. So you don't want fluids from a lower level getting and communicating to an upper level. So surface casing, the first string first casing string, which is joints of pipe screwed together, that is primarily to protect groundwater. So where we get our drinking water from, that's shallow in the earth. Okay, we want to make sure that we are completely isolated from it. And that's usually what your surface casing does. And then your following casing strings isolate different pressure regimes from one another. And then it's all cemented in. And so now we've got inside this wellbore, we've got a steel pipe that's got no communication with the rock whatsoever. Then drilling is complete. Drilling is finished. Sorry, I'll use my terminology. But now the next phase is we've got hydrocarbon, oil or gas encountered in a reservoir, sandstone or carbonate, a type of rock, a porous rock. Now we need to connect that hydrocarbon to our sales meter, or the refinery where it's being processed. So we've got to get it from the rock into the well, up out of the ground, so it can go to the production facility. So that process is what we call completion. And this is two examples here. Here you can see these little blue triangles are actually signify perforating charges, where there's explosives been fired through the steel pipe, through the cement, and into the rock. And that forms a pathway for gas or oil to flow from the reservoir into the well. This diagram, again, you can see it doesn't have the cement colors on it, but it still has these little triangles here. That tells us that this is casing and this has been cemented in place. And we draw it, our surface casing, and then this next smaller hole section and pipe. Again, these little triangles tell us, okay, that was cemented in place. When it was drilled, didn't have this sort of a hockey stick bend in it. It was drilled like we saw in the videos there, like a very progressive, smooth curve. But again, we're trying to represent the real world on one sheet of paper. So we just said, okay, this is a horizontal well. And here, this can be perforated or it can be open hole. So here, the label says perforation, but actually this sort of squiggly line is really, could just be that the rock was drilled and then we leave it, if the rock is competent, like it doesn't fall in. Sometimes you don't have to run steel pipe across it. You can just leave it open and let gas or oil come into the wellbore again. So this section of open hole is part of your completion, because completion is what gets reservoir fluid from the reservoir in the well and out of the well. That's what our completion is for. So again, this drawing might also be a deviated well. We just don't bother showing that in the drawing because we just want to see what's going on in the well. So we use this example just because it's a little bit easier to follow than a horizontal. So again, so we'll keep this picture up over here so you can kind of keep track of what's going on. And the first thing when we're completing a well is oil versus water versus gas. So in the reservoir, you can have gas, oil, and water show up in a wellbore. And what we'll do, one of the things we'll do is we'll run tools, electric line tools. Sometimes you'll run them while drilling, but you can run them on electric line or wireline on memory tools. And we're going to get readings like gamma ray, which tells us the type of rock, or resistivity. And so water is very conductive to electricity. So the resistivity is high. Oil doesn't conduct electricity very well, so the resistivity is low. So we can measure resistivity. That gives us an idea of what type of fluid is in the well. And then the other one is density. If something is heavy or light, also can tell us rock properties, but also fluid properties. So that's one of the first things that we have to do is what part of the reservoir do we want to connect to the wellbore? Ideally, water we don't want to connect, usually water, or we don't want to connect, or if we're just going for oil, then we know what part of the wellbore we want to open up to the reservoir. So the most common way to do that is called perforations. So this is connecting the reservoir to the wellbore. Again, you can do it in an open hole or different types of completions, but perforations is by far the most common. So in this cartoon here, this drawing, the dark gray, that's casing. So that's steel pipe. Here's our wellbore. So again, we're looking, we've cut the pipe in half and we're just looking at the two edges at us. And then because we ran this steel pipe and then we cemented it in place, so we pumped cement in here and let that harden. So then this is the reservoir, the formation rock. So then we have rock bonded to cement that's bonded to the casing. So we have a nice seal here where pressure, or because we want to keep all the fluids in their respective layers. And when we drill it, this is what we put in there. Then for the completion, what we're going to do is we want to put a hole in this casing through the cement and through the rock. So if we put a hole in there and we do that, then the gas can flow out of the sandstone into this hole, and then it goes into the wellbore, and then it's got a path up. So to make these holes in the well, we use they're called perforating guns or perf guns, and so because you're perforating holes, you're punching holes in something. So and what they are, so this is a gun carrier. So this is basically an explosive, gunpowder, and then this little cone here is a shaped charge. So the gunpowder will ignite. You run this on an electric line, typically. You can run it on a slick line, but typically you run it on an electric line because you want to get into again, looking at your log that we've run, where do we want to place these charges? Where's the oil or where's the gas that we want to connect to? And then you send an electrical signal. Same as like blowing up the dynamite, you're sending a signal down. It fires the gunpowder. This is basically a metal disc, and when it shoots, it deforms and becomes, in a sense, a sort of little bullet that then goes through the steel, goes through the cement, and into the rock. And here you can see that you could damage the rock close to the perforation tunnel. So there's some calculations you want to do to make sure you get your pressures right and the type of perforation charges. But this would be basically sort of what it would look like is you can, these, I guess, flashes of light are the explosives going off, and you can put blanks in here as well, so that depending on where your log tells you that your gas is or your oil, you want to perforate here. You don't want to perforate this. You want to perforate here, here, and not down here. There could be water here, could be water zone here, if this is horizontal, for example. So that is, again, part of the completion. We now have and we draw it on our cartoon with just little sort of longer triangles, because it's meant to represent an actual perforation tunnel. And these, so if we look at the scale, if this is a 7-inch casing, so say that big around, say 7-inch, something like that, about 180 millimeters. A perforation charge, depending on how much gunpowder you put in there, how big the guns can be, because they got to fit in your well. You're probably going to shoot 6 to 12 inches into. It also depends on the rock, but you're probably going to get that far out from your wellbore. So, which is actually, and maybe this big around. So, which is pretty impressive, because this is very compact rock normally. So, but that's enough to get connection with the reservoir. So that is, again, and I'm doing this from the bottom up when we're completing a well. the order in which sometimes you run other parts of the completion first. Again, it depends on the situation. But this part is now getting reservoir fluids into our wellbore. Now what? Well, because we have this casing that it's cemented in place, and hopefully the well is going to be in use for 20 or 30 years or more, who knows. We want to have the ability to, the part of the well that sees the reservoir fluids flowing past it, that we can change it out. So we protect the casing from, we run another pipe. And because we don't cement it, we don't call it casing, we call it tubing. And so it comes in about 9-meter or 30-foot sections, and we'll run that in the well. And so this is just a little, so this is the derrick man. So he's up in the derrick of the drilling rig, and what they're doing here is he's gonna put this in the elevator. So the driller down on the rig floor is raising the drawworks, raising this up the elevators, and then he's going to put that pipe in the elevators. They'll bring it over top of the well, screw it into the bottom joint, and then they'll run that in the well. And so normally, because the pipe is, say, 9 meters long, if you can pre-screw these pipes together, say 2 together, they're almost 20 meters long or 60 feet. That's why a drilling derrick is so high. That's why you can see it, is because it saves a lot of time to have as many joints as possible screwed together, pre-screwed together, basically what you're doing. Because you're going to screw these all together and run in what we call the tubing string. And you see a little sort of an X thing here. That's a packer. And so in rod pump wells, you wouldn't have a packer, but a lot of wells, you'll have a packer, and this is what a packer looks like in real. You'll have a packer screwed onto the bottom of this pipe. And what it is some metal slips and then elastomer seal. And what that does is causes a pressure seal. Oops. That causes a pressure seal between where the bottom part of the well and between the tubing and the casing, so that we don't get any reservoir fluid affecting the casing that we have behind the tubing. You may have you'll have some down here where the reservoir rock is, but you want to set this packer in your next competent layer of rock, so you got a nice good seal. And so a production packer and production tubing, and then then you have production tubing, and outside of it is your casing. The space between the two is what we call an annulus. So it's like the donut, but it's the space between these two pipes, and we monitor that during production for pressure, just to make sure that there's no leaks between the two, so that way we know we have good well integrity. So super important job to get good connections, good pipe, a good seal, so that we've got our reservoir fluids, oil and gas coming into the wellbore, and then they're going to flow up the production tubing where we can control the flow. So that is the that's again, so we're still doing well completion. And our last part of well completion is at surface. So now we got our perforations, we got a connection to the reservoir, we've got our production tubing. So we've got a conduit for oil and gas to come to surface. And then it comes to surface. Well, now we need a way to, so this is a well here. Tubing will be coming up to right around here. And then we've got a collection of valves at the top of the well. Because it sort of looked like a Christmas tree to people, we call it the Christmas tree. So maybe you had to have a bit of imagination to see it as a tree, but the name has stuck. It's a tree. It's a Christmas tree. So again, here, this cartoon, the production string comes up. And at the top of the production string, there'll be what's called a tubing hanger. Because that's a tubing string, there's a bigger piece of metal at the top that the tubing hangs off of in the wellhead. And then the Christmas tree, again, is just a collection of valves so that we can control the flow. Because we don't want this coming to surface from the reservoir through the well. Okay, now we've got to control it for when it goes to the production facility. And so here's, in the pump jack scenario, we've actually got a pump run, a beam pump, a rod pump in the production tubing to help us lift some of that fluid out. But the perforations and the production tubing, that's all the same. Just when it gets to here, the fluid goes up and goes down the flow line, and there's usually a valve here on the flow line. And then this is just a seal for this rod going up and down, which here is failing a little bit. But then for the rest of these, this is onshore wells, gas wells, another gas well. You can see this one's got a bit of a bend in it. That's a high rate gas well, so to limit erosion, there's some changes there in geometry. And then this is offshore, but it's it's dry trees on a production platform offshore. That is offshore Australia. Again, a Christmas tree is installed as part of completing the well. It's a collection of valves for us to control flow. And then also, same thing in a offshore or subsea environment. The tree looks a lot different because we need to operate it with a remote operated vehicle, the robot arm. So it looks a lot, like I say, it doesn't really look like a Christmas tree at all anymore. It looks kind of like a box. But again, it's just a collection of valves for us to control the flow. Excuse me, control the flow. So when you hear completion, it's basically, that's how you get the fluid from in the reservoir to surface, where it then can be controlled, can go to production facility in a controlled way. So yeah, that's completions. So then we go from a drilling phase of well construction to the completion phase of well construction, and then the well is ready to be handed over to production operations, where they can produce the well, and then we get to the intervention phase, which we'll talk about again next time. So again, thanks for your time. Appreciate you tuning in. If you want to sign up for the webinar, again, it's Wednesday evenings, go ahead and use that. And then if there's videos that you may want to rewatch or that you missed, you can go to YouTube/Ballycatcher and review this at your leisure. And if you have any comments or questions, you can also put them in the YouTube comments as well. So, because again, this video was triggered by someone making a comment about the review completions. If there's anything you want to review, just put it in there, and we can also go through it. So, just check. Okay, well, I think that's it for the comments and questions. Thanks a lot, and we'll see you next time. Thank you.